As I said at the end of the last video, we hope to be able to factor things that we couldn't factor before. Well, part of doing that means being able to divide by certain factors. And if those factors divide evenly, that helps us determine that that can be a factor of that polynomial. Let's take a look at what I mean. We're going to do a little bit of review here of long division, and we're going to introduce synthetic division in case you haven't seen that. We are then going to use that to find the remainder theorem, and then the remainder theorem gives us the factor theorem, which is the true value in all of this that we're working on. So let's see how that works. This first part is just a reminder of how we divide real numbers using long division. If you remember, let's get a color you can see a little better. If you remember, when we divide 2,312 by 12, we put the number that we are dividing inside the house, and then the number you're dividing by goes outside the house. We look to see, does 12 go into 2? It does not go into 2 by itself, but it does go into 23. And we're not really looking to see if it goes into 23. We're looking to see if it goes into 2300. And the answer is, yeah, it'll go in there 100 times. And so we're going to put a 1 there to represent that 100. But shorthand, we do this, right? We write the 1 above, we multiply the 12 times 1, write it below, and subtract. We get 11. 12 doesn't go into that 11, but if we bring the 1 down, we can now see if 12 goes into 111. And it will go into that. It won't go in 10 times, but it probably goes in 9 times. Let's see over here. 12 times 9, 8, carry the 1, 108. Yes, it will. So we're going to write a 9 here because 12 times 9 is smaller than what we have in that 111. We multiply and then we subtract. We get 3. We had already brought the 1 down. Now it's time to bring the 2 down. How many times does 12 go into 32? 2 times. That gives me 24. When I multiply the 12 times the 2, I subtract and I get 8. So remainder 8. The result here is that 2,312 divided by 12 is equal to 192, and that remainder we write plus 8 over 12 because that remainder really has not been divided by the 12 yet. There's nothing to still carry down, and the 12 can't go into 8. So we have to divide the 8 by 12 still. We don't typically write 192 plus 8 over 12. We typically just write 192 and 8 twelfths, but 8 twelfths will simplify down to 2/3. They're both divisible by 4. That's how division of real numbers works. If you don't remember this, if it's been a while, practice this. If you need more examples, you can find some YouTube videos, the explanations in ALEX for long division of polynomials will help. So there are resources available for you, or feel free to reach out to me and I will be happy to help you. The algorithm for dividing polynomials using long division is exactly the same as the algorithm for dividing real numbers using long division. Whatever we are dividing by, so it says divide to determine if x minus 8 is a factor of that. We put the x cubed minus 9x squared plus 6x plus 16 inside the house, and outside is the x minus 8. When we did the division of real numbers, we looked to see if 12 went into the first thing here, the 2. It did not, so we moved on to the 23. We're going to do the same thing here. We are only going to focus on the first part here, though, because the rest of the stuff will work itself out in the work we do. So how many times does x go into x cubed? Well, another way to ask that is to say, what would I have to multiply x by to get x cubed? And the answer is x squared. Now, when I came up here, this 12 right here came from multiplying 12 by 1, the number I excuse me, the number I wrote up above. This 108 came from multiplying 12 times 9, what I wrote up above. This 24 came from multiplying 12 by 2, which is what I wrote up above. So what I write down below in long division of polynomials is the product of what I have over here and what I wrote above. Just like up here, the product of 12 and what I wrote above is what went down. So we do that, we get x squared minus, x cubed. When I multiply x minus 8 times x squared, I get x cubed minus 8x squared. Just to be clear where that comes from, I am multiplying the x minus 8 times what I wrote above, the x squared. When I distribute that, I get that, the x cubed minus 8x. Now, my next step above was to subtract that. I am going to subtract here as well. But I have to subtract the entire polynomial. So I can put parentheses to subtract that entire polynomial. But I know when I distribute that negative, I'm going to have to change the signs. So I may as well just go ahead and do that. So I subtract the x cubed. I subtract negative 8x squared, which means I add it. That x cubed minus x cubed is 0. This gives me negative x squared plus 6x plus 16. Then I go back to my x minus 8, because up here, after I subtracted, I went back to my 12. And I see what would I have to multiply the x by to get negative x squared, and that's negative x. Then I actually do multiply that. In this spot, I am going to write the x minus 8 times that negative x, which gives me negative x squared plus 8x. And just like before, I subtract that whole thing, which changes all of my signs. Changes the negative x squared to a plus. I get negative x squared plus x squared will give me 0. Now I have 6x minus 8x is negative 2x plus 16. Now I go back to my x minus 8. Just like above, I went back to my 12. I am looking at negative 2 is what I need here. Remember, I multiply x minus 8 times whatever I wrote up there, which is negative 2. That gives me negative 2x plus 16. And I always subtract. I subtract the whole thing. It changes my signs. And down at the bottom, I get 0, which is my remainder. I have nothing left to bring down or deal with. It's all gone. That tells me x cubed minus 9x squared plus 6x plus 16 divided by x minus 8 is equal to what I have written above, x squared minus x minus 2. The question says divide to determine if x minus 8 is a factor of that big polynomial. If we think about some algebra that we could do here, we could multiply both sides of this equation that we have above by x minus 8. And we get that by multiplying by x minus 8 on the right. If we multiply by x minus 8 on the left, these simplify away and just give me that numerator. Now that we've seen that, let's ask the question, is x minus 8 a factor of x cubed minus 9x squared plus 6x plus 16? The answer is yes, sure. Look, we rewrote two equivalent things with x minus 8 as a factor. The reason for that is because this remainder was 0. There was nothing else added on or tacked on over here that would have made that difficult. We're going to look at that a little bit more. Let's do another example of long division because this is not an easy thing. I'm going to do this one, go through this one a little bit faster, so if you need to pause the video, then feel free to do so. The main reason I wanted to look at this one or one like this is because this is missing a square term. So for some of you, you may find it helpful to write in 0x squared in there so that you don't forget it in your work. All right, up here I'm going to write 3x cubed because that's what I would need to multiply x by to get 3x to the 4th. When I do that, I get 3x to the 4th minus 3x cubed. I have to subtract. 3x to the 4th minus 3x to the 4th is 0. I get x to the 3rd. I'm going to bring down the 0x squared plus x plus 4. I'm going to bring all that down. Now, how many times does x minus 1 go into x cubed? The answer is x squared. I'd have to multiply by x squared. When I do multiply that, I get x cubed minus x squared. I got to subtract. Changes all my signs. The reason I wrote this 0x squared here is because when I subtract the x cubes, I get 0, but when I add these, I do get an x squared there. And I'm afraid that if I didn't have that there, if I had squished this x plus 4 over, that I might try to combine things that are not like terms. If this x plus 4 was over here, I might try to add x and x squared. And those are not like terms, so when I add them, I can't combine them. That's why it's a good idea just to keep that spacer of 0x squared, just to make sure. Next, we're going to put an x here because that'll give me x squared minus x. Let's subtract that, which changes the signs. Gives us 2x plus 4. I'm going to put a plus 2. 2x minus 2. When I subtract that, I'm going to get positive 6. So I get remainder of 6 there. The important idea here is that when you have a remainder that is not 0, the divisor is not a factor of the numerator. If the remainder is 0, the divisor is a factor of the numerator. Okay, I do want to try to write here this 3x to the 4th minus 2x cubed plus x plus 4 divided by x minus 1. I want to write this result here. from what we have up here, it is 3x to the third plus x squared plus x plus 2. The question becomes, what do we do with that 6? And the answer is that 6 has not yet been divided by x minus 2. We haven't done any work on it. I'm sorry, x minus 1. So it has to be written as 6 over x plus 1, x minus 1. And that is why this x minus 1 would not be a factor, because if we did try to multiply this equation, both sides of it, by x minus 1, you're going to get some addition in there in addition to the multiplication. And it's not going to give you a factored thing like we had up in this previous example. Okay, that long division can get very cumbersome. So we have another process called synthetic division that can help shorten long division. It only works if you are dividing by x minus a constant real number, like this example, like the one we just did. I think it's the same. Yep. So we're going to do this using synthetic division. Exact same thing, we should get the exact same results. Here's how it works. We write the coefficients of that numerator. I'm going to write 3, -2. Here, you absolutely must fill in a 0 because we are not writing the variables, so we can't keep track of them. We're going to write that. We're going to leave a little bit of space and draw a horizontal line. I'm going to write what we are dividing by over here. In this case, it's going to be 1 because we are dividing by x minus 1. So that minus sign, it's sort of taken into account there. Sometimes people want to put -1, but it's just 1. You bring the 3 straight down. Then you multiply the 1 times the 3 and put it there. And now we add 1. Now I multiply the 1 times the 1 and put it here. And I add 1 times 1 here, and I add 1 times 2 here, and I add. That last thing is always going to be my remainder. The other numbers are going to be my coefficients on my, my result here after I do my division. Because I was dividing x to the 4th by something with x, I know this is going to be x cubed. Then plus x squared plus x plus 2. So you're just counting down as far as the degree. Sometimes I like to just count backwards. The 2 is the constant, the 1 is the x, the 1 here is the x squared, this will be the x cubed. And of course your remainder still has to go over x minus 1. That is the exact same result we got when we did the long division. But you can see that synthetic division is quite a bit faster once you get comfortable with it. I only put one example of synthetic division here in the notes because we are going to see it pretty extensively through the next few pages of notes and through the next few videos. So you'll have plenty of opportunity to see more examples of that. I'm going to stop here so this video doesn't get too long. We'll come back and talk about the remainder theorem and the factor theorem.